Good afternoon, everybody. It's 3:19 here on the West Coast, 4:20:24. Yeah, you know 4:20. Come on now, don't be laughing at us. Anyway, hello, everybody. It's Joe from the Joe Slick Live Show, and we have with us Canuck, better known as the New Brunswick, Canada guy, and our other cohort, Lou Klimmer. He's going to be on, but after he gets all ungreased up because he was working today, as I was, and I just finished and had to gulp down a quick meal. Hopefully I don't, work one out. But anyway, just teasing. God bless America. Don't get so all worked up. Yeah. Yeah. So back to it. Solar wind right now, again, I'll tell you for those of you who are just tuning in, is 410, densities at 1.6, a couple of C7 flares. We did have a strong geometric storm. We had a G3 yesterday. Surprised the heck out of everybody. And if I went to this doohickey here, you see yesterday we did have a couple of M's, and today no M's. That's okay. We're not looking for an M, right? And here it is. The KP went all the way to 7. Was the G3. It was at G 6. It was G2. Then boom, it went up a little bit higher. And that stems from what was going on here. I think they've updated so much so I can't see it. Okay, yeah, I got it. Here's the 19th, and yeah, they don't have it. Yeah. Alrighty then. Well, that's what's coming up too, baby. There's some wind and stuff. I know, Canuck, you probably can't see what we're looking at, but
yeah, I can see it because I'm looking at JSL's screen too.
There you go. Looking at Mexico, because Mexico 8, man, Mexico's in the news. I don't know what anybody's saying to you. It sure the hell isn't the USGS. They've got 1 quake, 2 quakes. And, in the last, how many days again? I think I have 2 days on here. And look at all the quakes in Mexico in 2 days. And what's disconcerting to me is a lot around Colima. Colima volcanoes over here. And you know what happens when that thing goes off. Also, we still have a huge swarm happening in central Baja offshore. And we do have another one up here, another 4 that happened just a little bit north of that. And that's over by a volcano that's up here. And a smattering of smaller quakes in the local area here over by the Delta. But down here in this is the only one USGS has, is a 4.8 in the south, almost on the border of Guatemala, in Chiapas. Interesting. There's a bunch of them out here. Plus, going over to the other state, I forget what it's called. Damn it, Veracruz. Yeah, Veracruz. There's the city. Yeah, over towards Veracruz. I told you the chicken leg's breaking off from South America. It's moving. Why is it moving? Well, the Pacific Ocean is dragging it with it, as it's dragging the whole east or west coast of the United States. Yeah, it's all moving, in my opinion, that is. And looks like Fresno just had a little 2.5 home guards, I'm going to call that. Basically Fresno. Nevada had a little 2.9 today. Yeah. Texas, interesting, 4 quakes in Texas here. We got a 2.5 in the southern part. In the west, 2.7 Toya. This is interesting. Right on the border of New Mexico. Still in Texas, though. 2.9. And then north of San Angelo and east of Midland, another 2.6. And, of course, 4.4 in Laredo and a 4.4 in Laredo yesterday and then today. So interesting how that's popping up. And up here in the Blanco fracture zone, we have a 3. And then up on the border of Washington and Oregon near Kennewick, we have a little 2.8 showing up in the west. So as you can see from the DR all the way up to Washington, seems like there is a whole group of earthquakes. Well, there's movement. And why is it only in this northwest to southeast? Or is it another way? You care to comment on that there, Canuck?
Well, most of the lineaments that are on the west coast are northwest to southeast.
Right.
The main
And
ones.
for those people who don't know what a lineament is, can you give us your interpretation of what that is, basically?
Well, I'll give the story. So when I started looking at all this stuff, I started watching the specs, and I saw when a bigger quake propped, it didn't go like how you think it would go. It would always prop in in a straight line over like a large distance. So then I started thinking, well, why is it doing that? So then I started looking up like felt reports on historical quakes, and I found the ones in the past did the same thing. So when there was like a big quake in, well, let's say somewheres in California, like around LA, if it's big enough, it will prop certain ways up certain lineaments or faults. And I kept seeing this over and over. So then I started, well, I'm going to try and figure out what this lineament thing is, because they used to call them that back years ago. All the seismologists, geologists.
Right. They didn't know about the faults in the west.
Yeah,
so
so that's what they called them originally. And so then they said, well, we're going to try and identify where they all are. So this all started like way back the same time as plate tectonics and all that stuff back in the 60s originally.
Late 60s, early 70s, yeah.
Yeah, so it's been going on since, and they've changed, the people that focus on it have changed the name of it several times. And so they set up where they had like conferences every year to talk about the lineaments. So that's what they called them at first. But then they changed it to basement tectonics. And now the current name they have for it is called neotectonics. So you have to like research all those three things now to understand like all the, because it's people doing it all over the world, right? And then they usually ended up working for like whatever the local agency is there that's like with natural resources. So in the US, of course, it would be the USGS, because most of the geologists would end up, or seismologists or whatever, would end up all working either for the government or for private companies, either mining or oil exploration or all that, any of that type of stuff. So once I found that out, I said, well, I'm going to have to start investigating like how all these people figure all this stuff out. And so when I did, I found out, of course, that it's all related to mining, and it's all related to oil exploration, and it's all related to getting natural resources, which that's what all this stuff relates to, because the geologists and the seismologists and everybody else is trying to figure out the earthquake thing and where the fault lines are. It all relates to magnetics, because that's what they actually used to find. That's why the mining stuff is where it is, because it's all generated from magnetics and high pressure and heat, where all that stuff would come up. So it doesn't matter if it's a volcano or fissure volcanics, anything to do with mining and natural resources that we use for everything, or mine or try and retrieve, it's all related to that same stuff. So once I got into this more and I started investigating mining and oil exploration and everything else, I found out that it's all related to magnetics. So then once I saw that, well, all the faults then are all related to magnetics. So once I started doing all this stuff, that's when I made the connection with like different things that people call stuff. So they call ley lines, for example, are the same as lineaments. It's just that whatever side you're coming from, that's what the people that tried to access the magnetic field lines of Earth call them ley
When you
lines.
say one side, you're talking about from one discipline to another. They each have
Yeah.
their own different names, and that's what you mean, right?
Yeah, they're actually talking
Mhm.
about the same thing. It's just that they're coming at it from whatever angle they're coming at it from.
From a different discipline, yeah.
Yeah, so they're all talking about really the same thing. It's just that they say it 2 ways or 3 ways or 5 ways or 6 ways or 10 ways. And the more I started looking into the tectonic stuff, the more I found these names. And that's why they've changed them over time. They're still talking about the same things as the lineaments, but now they call it something different. So they call it basically
Neotectonics, yeah.
tectonics or neotectonics because
Mhm.
they just like changing the names of things.
Well,
So
here hold on a second. From the book on geomorphology, second edition, 2022, neotectonics is a subdiscipline of tectonics, is essentially a synonymous with the active tectonics. As such, is a study of contemporary motions and deformations of Earth's crust, including those of very recent geologic past. And what is what is meant by neotectonics? It's the study of young tectonic events which have occurred or are still occurring in a given region after its orogeny or after its last significant tectonic setup. So that's what the internet will tell you what neotectonics is. So it's a subdivision of tectonics itself, the study of the land, right? And you can continue with your story. I just wanted to add that little bit because study of deformation of rocks that make up Earth's crust and the forces that produce such deformation. That's what tectonics is. Neotectonics is a little bit different. It's the study of young tectonic events which occur or are still occurring in a given region after its orogeny or after its significant tectonic setup. So it's kind of contemporary motions and deformation of the Earth's crust, like what's happening today. Like he would say, the people that are talking about ley lines or lineaments are the neotectonic people because they're still happening today. Whereas tectonics says this is the way it all happens. But what they're doing is they're studying why is it right now happening only along a line? And that's kind of the difference between the two. One is kind of overall and what is a subdiscipline. And I think if I can put words in your mouth a little bit, I think that's kind of where you and I agree on, and we're more interested in is the current events happening, but also allowing 300 or 400 years to, which is relatively young in tectonic motions, to see what's happening today, and then contrasting it with what happened 1,000 or 2,000 years ago, or even 25,000 years ago, to see where the plate's moving and why is it moving in a kind of generalized area. And that's kind of why we make the suppositions that we do. And I think helping people understand the reason why we look at the Texas lineament specifically, whereas I might define it just a little bit different than you, but I got it from the Blanco fracture zone all the way to through California, Nevada, Arizona, New Mexico, and into the Texas, and popping out Corpus Christi, and then closer to the Dominican Republic, and then somewhere up in the mid-Atlantic ridge in through parts of Africa, Zimbabwe, and Nambia, Angola, and then towards Caligula, or as I would call it, Caligula. I don't even know what the name of the place is. French Southern Antarctic Territories, Kerguelen. Yeah.
Yeah.
So, and there's a reason it goes all, even for me, it goes up into Alaska too, and somewhere not quite as high as of Kodiak, but between Kodiak and these other islands in the south here. So somewhere in this front side of Bristol Bay, the Patton Seamount, basically. I don't know if you define it quite like that, but because there's other lineaments that clearly are different, like the owl, the which it's the Olympic Walla Walla, through Kansas lineament, Kansas City, and that goes through the park, almost through the park, but pretty close to the park, and through Kennewick and out that way. And there's also another line of this crack or a strike slip here. I don't know if they're seeing that. Let me see. Yeah. I don't know what fracture zone they don't even have a name on it on USGS, but it leads from the, basically the Seminole Mount through the Olympic Mountains, Kennewick, and out, out this way towards Kansas City.
Yeah. That's the edge of the Explorer microplate.
Yeah.
That's where it is.
Yeah. And these things are relatively current.
Yeah.
Now, how they became active is what we're kind of, I think that's what drives our interest, is why are these things active today versus, 50 million years ago when they were being formed, when Silesia came ashore and smacked up North America, and Wrangell, at 110, 120 million years ago, scooted all the way up the coast into Alaska. And so it's like parts of something's way up here from way down south. And for me, the Murray fracture zone, the Gorda escarpment, or the Mendocino fracture zone, 40 million years ago, were down here at the end of Baja, or even in San Diego. I think in San Diego, it's 800. So maybe not quite maybe San Francisco, and moved up about 400 miles every 40 million years. So if you move North America east and you move the Pacific Ocean south-southwest, which is the opposite of all these lineaments. See, it's like the lineaments are going along the direction that the Pacific plate's moving. So there's an intrinsic relationship between the two. And it's almost like the Pacific Ocean is coming out from underneath North America and moving north. It's almost like it. Not that it is. It's almost like that, because North America, and you have to back it up so far, and then pull out of the trench what went in the trench, and then lower these mountains, and then stretch put back together the basin and range and all that. That's complicated, but the more you look at it, the more you study it, the more it starts to make sense. And it is what it is. Even Brazil and the Cocos plate and the Nazca plate. If something cracked the hell out of it, and if it was all one plate before, pretty interesting, man. Brazil and Argentina and all of South America, pretty big. How did it move so far away from this plate boundary? How did Africa move up north? It's moving northeast. And if they were together at one time, What's driving the movement?
Well, I guess I've simplified it
Go ahead.
using my ice movement thing, because I've seen how it does that. Because what I think the lineaments are the actual magnetic field lines of the Earth coming from the core, and they actually move everything.
Yeah, I am inclined to agree with you on that because I've seen some interesting anomalies that I can't unsee or unsay and throw out. You know, there are unique boundary lines that are invisible, and I don't know exactly where it is. Where's that?
But I don't think they're invisible to us now because we have the technology to see all this stuff in real
Right.
time now. And that's the difference. And you can see it doing
Mhm.
it the same thing over and over. So the quakes actually follow the lineament lines. That's
Right.
how they do it, because that's how it explains the ones that are in the center of a plate that they call interplate quakes, and
Mhm.
they always say, well, we're not so sure why it's doing here in the middle of nowhere, because
Right.
to our knowledge there's no big faults there. But then when they go to actually study it, they say, oh crap, here's a fault. and
Right.
and what the faults are, they're the evidence of the lineament, because they always go in a direction. So
Uh-huh.
you'll find once you start studying faults, you can go and look whatever one it is, whatever one they want to call it, and however
Mhm.
long they decide it is. They always go northwest to southeast, northeast to southwest. They go east to west, or some very few north to south. But you can find them, if like in Iceland now, they're finding all the particular ones, like where it's rifting there.
Well,
And
would those be a lineament line, or would it be like a response to a lineament line?
well, the faults are the evidence of what the lineaments are doing, or the magnetic field lines of the Earth, if you really want to
Yeah.
simplify it, because that's what it actually is. And that's what the neotectonics people, that's what they would call it if you could sit down and
Right.
interview them, because what they're doing, they're studying everything under the crust. That's what they're focusing on and trying to figure out
Mhm.
why the stuff is where it is, because a lot of them are in mining, and they're the ones that mapped all the places where they're going to look
Yeah, there's a
for
lot of perforations
gold,
in the world.
copper, whatever.
Yep,
Yeah.
looking for oil, looking for natural resources. They're hammering the world all over the place.
And the neotectonics people, once they identify a lineament, if they even still call it that, because
Right.
I'm going by what the original name, but it's always in a straight line. And it keeps going because they've found out from doing their stuff that
Then it
once you
circles the
identify a
world.
lineament line, yeah, it encompasses the Earth, so you can go right
Mhm.
around the Earth once you start following it, and all along it, you should find all the resources, even if it's underwater, because it
Right.
doesn't matter, right? Because the magnetic field lines of the Earth are still creating the stuff even underwater. So if you want to get to it, you have to go underwater and then mine it out of the ocean crust, which is, I can get into a whole side tangent on that, because that has to do with the people that are mapping the ocean, because they're all tied in together. They're same
Well,
as the natural resources.
summarize it. Just summarize it real quick.
Well, that's what they're doing with LIDAR, and all the smaller companies that used to map the ocean have now all bought up, and they're all under one thing from the Netherlands. And you'll find out the same people are the same ones that are doing like all the ocean mapping projects and all that. So like say when the USGS wants to go out and check out all the seamounts off of Washington, they have to get a boat, of course, to go out there and do it. Well, that same company controls all the boats that they use to map the
Mhm.
ocean. And the people that are out on the boat, other than the geologists and whatever working for the USGS or whatever the national agency is, the people that actually crew the boat actually work for this company from the Netherlands that does all the mapping. And so they're the ones that are all organizing it, which by 2030 is their goal, is to have all the oceans in the world mapped. It's not going to happen because they're, unless they pick up the pace way faster than what they're doing now. But that's their goal. So you'll find a lot of these projects are all have the goal is 2030. Whether or not they get them done or not, it just depends on how fast they do it and how many people they have actually taking part in it and everything else. But anyway, so it all goes back to the neotectonics thing and finding where all the resources are that the planet needs for everything. And it doesn't matter what it is. It's copper, gold, it's lithium, it's whatever. All that stuff is all based upon what these geologists are mapping all over the world and trying to find stuff so we can have all our fancy dancy technology and everything else that we have. So when you start reading about mining and faults, you'll find out that's why all these companies have all this information. So if you actually want to find out about the faults that are in your area, you end up reading a lot of mining studies or oil searching studies or whatever, because it's all those companies that are studying their area to find the oil or gold or whatever it is, or lithium or whatever, and they find where all the faults are because the faults are where all this stuff is, because that's how it gets up close to the surface so we can actually get it. Because most of our mining that we're doing is not going down any farther than like 3 kilometers max. And that's like the deepest stuff. So it has to be close enough to the surface that we don't have to go down too far to mine it. Now we can go down.
It might be a good thing too that we don't go down that far.
Yeah.
I mean, now, what happens if we remove all the magnetic material along a certain limit? Well, that might be bad for us.
Well, I don't think we could ever remove it because it's always making more, because that's what it's doing in Iceland right now, right?
Well, yeah, because I just, oh my God, just burnt my eyeball.
And that's what it's doing now in Rayong volcano there too, because now they're afraid that's going to blow up again because it's all plugged.
Right.
And now some of them are thinking, because how those islands there are all close together, and they've been looking at the islands and they're going, oh crap, this could be like, because how they're formed, it's like the ones they found up in the Aleutian Islands. This is like a friggin' caldera, because they started looking at the other islands there. This all just happened in the last few days. They've looked at there's other islands where the old volcanoes were on them that aren't active now, and then they looked at the earthquake data, that all the little earthquakes have been happening like since the eruption there in Indonesia, and they looked and said, oh crap, this is like doing it at the dormant volcano. Well, of course they think they're dormant. So, and they're all in like a big ring, like a big gigantic caldera shape.
Yes, sir.
So now some of them are actually thinking that where that volcano is actually part of a larger caldera. The same as what they found out of the one there a couple of years back in Alaska, in the Aleutian Islands. There is actually a caldera, and it has a whole bunch of little volcanic islands around the outside of it. So now they're worried that that thing can go way bigger than what they thought it could. So now they're saying, well, this thing.
You can look at what is that that volcano here in New Mexico, which we studied a while back. The Millennium Falcon. You know, where is it? Let me see. The
Valles.
Yeah, Valles. Yeah. That thing was a big volcano at one time, and then it blew itself out, and then Valles happened, and it blew itself out, and a bunch of other little volcanoes all around the caldera itself were created. Put that underwater. That's the same thing. That's what you're talking about.
Yeah. And now what they're worried about in Iceland, this is the latest in the last 24 to 48 hours. They're worried now a new eruption's going to come up and they're going to have two going at the same time. And the scientists that are thinking that are some of the same ones that are thinking, well, how is this thing like just one big gigantic volcano with edges or what? Because all the stuff they're trying to figure out the magma chambers that are under there, like the Svartsengi one is just a little dinky thing,
Right.
but the big gigantic one that's down deeper is now
It's
well,
underway.
they think,
That's
well,
where the
it's
big call there.
basically yeah, it's basically everywhere's
Yeah.
up there, and all these places where it just busts through, it's just the little offshoots of the super big magma chamber down underneath everything farther down in the crust. So when it comes up and does all that, it starts its routine, and it just so happened that it started in 2021 there in Bagrados's Fall or whatever, which they think is where it came up first. But see, now it's like moving west.
Yeah. Well, this is
So
you can see
right,
just the topography would show you that there is some roundness to it here. I'm showing you on the map. There is a volcano right here, and Grindavik's down here, right?
Yeah.
But just north of Grindavik, almost due north, there's a larger volcano that's right here. And if all these little things are happening because they're the weaker part of the plate, you know, this big monster might go. And if that goes, well,
Yeah.
bye-bye airport. Well, I
and
think
they're doing more work on the western walls by Grindavik too, all in just the last couple days, because now they're afraid that it's gonna like break out slightly to the west. But
well,
they
there's no
also
reason- I'm sorry, go ahead.
they also said it could break out right in Grindavik itself, which if it does that, it's not going to matter anyway. But because how that line goes there, that's northeast to southwest, it goes right under. And they said because it's already erupting in the current spot where it's done like several times now, if it tries to come out again, it may not come up in the same spot. It may move like farther down that line or switch over to the next side. And that's what they're worried about now. This is all in the last 24, 48 hours, because all the dueling scientists up there are all giving their opinion, and some are agreeing and some are not agreeing. And they're saying, well, we might get caught with our pants down if we don't do this. And then so they're all scrambling trying to figure out, well, we better do this just in case it decides to jump over here, because we really don't know what it's going to do, because it's doing something different than what it did last time. So we better be prepared for it to do something different, or otherwise could get caught. And so that's what they're doing with, well, it's the same thing with the volcano in Indonesia. It's all the same thing, right? All these different people are looking at it and saying, well, this is doing something different than what it did the other time. So we better figure something out here, because it may not be going to do what we think. So we better
right.
Like in the latest report there from the Met Office, they actually put in like what they thought it was going to do, and they had like 4 different options, and people were going, well, what the crap, what are we supposed to do with that? And one of them was, if it came right up right in Grindavik, well, then it's not going to matter about your defense walls, because
I was looking at Newfoundland, saw it there too.
Yeah.
There's some
it's just
topographies here. You can see some roundness to the topography. This is all volcanic material. I mean, the whole area is loaded with volcanic material. You know, and even next to the airport, you could see. It's like, hey guys, you live on a volcano. The whole thing's a volcano. You know. So.
Well, technically, the entire Earth is made up of that. It's just some are way older than others.
Right.
Yeah.
Well, like we learned yesterday in one guy's study. He's a videographer, and I played him for the educational purposes. And And he talked about a interesting event that happens in Arizona here, where I live. There's like over 600 volcanoes in Arizona. It's like, what? Yeah, they're bunch of cinder cones. And, you know, in the town that I live, which I'll show you a picture here shortly, you can see ancient lava flows, much like what Professor Nick showed where he lost his hammer that time.
Yep.
In my city, there's a whole group of those things where the lava came out and just kind of like froze there. And then it cracked and like it looks like a bunch of pencils put together, you know. And it's a trip, but let me see where am I?
Well, basically, all the land that we live on came from a volcano at one point, or was volcanic in origin. That's just how it works.
Yeah. Oh, I don't have my phone.
Because it was magma, then it became lava, then it became rock.
It does in front of me.
So
Little knucklehead. I'm glad you didn't see that. I'm looking all over for my phone on my desk, and it's right in front of me.
That's when you can't find us right in front of you.
Yeah, I have an allergy attack right now, so it's not fun. But you know, is what it is. Working through it. Was that it? No, that's another thing.
But getting back to the liniment thing, when I started figuring out where all these ones were, I had to look up the original name that they called it, like when they first started studying them back, like say in the 60s or whatever. So when you look up that stuff, you have to look up, well, they usually have the word liniment in the name. So that's where they came up with the Texas liniment. Right. Or the Olympic Wallowa liniment, or whatever. So when you first find these things, that's what they're called. But when you extend them out, you can keep adding more names to them. So you can, so like if you followed the Olympic Wallowa liniment and then you kept going with it, well, it basically goes all the way down through Florida all the way to Puerto Rico. Well, I could keep going with it. So you can keep adding more names to it. And same with the Texas liniment. So Texas liniment, from what I found out so far, actually goes from Sand Point, where the big earthquakes were, all the way down through Corpus Christi, through the Cayman Islands by Jamaica, where the 7.7 was in 2020. And you keep on going, it goes right past La Soufriere, which blew up in 2021, and then you keep going all right down. It goes through Tristan da Cunha in the Mid-Atlantic Ridge.
These lines that he's talking about and I talk about, they're not like, you know, pencil-sized nines. They're 50, 100, 250 miles wide, and they have a vibration. So they have a peak and a valley in their signal. So they have a frequency.
And they keep going. So you have to refer to one to make people understand what it is you're talking about. But there's way more than just one. And some are more active than others. And you can actually find information about these things. But I guess I understood it better because I'd been studying the faults too, because they name a fault, but a fault is just a crack in the earth, right? So a crack in the earth doesn't care about borders. So we tend to name faults and we stop them at certain places when they go out of a border that we don't care about. But that's not how the fault doesn't care about that, and neither does a liniment. We can name them whatever we want. It doesn't matter. The crack in the earth just keeps going because that's what it does. So when you start doing this, if you start looking up a liniment, you find the name of it, and then you find out which way it goes. Well, which way does the Texas liniment go? It goes northwest to southeast. Well, if you keep going northwest, where does it go after that? Well, you just keep going right around the earth, or you go the other way keep going southeast and keep going, you come right around the Earth because the Earth is round. So eventually you come right back to the same point again. And that's what the neotectonics people are doing. So all along that line, you should find evidence of mining, oil, whatever, all sorts of natural resources. And I've done this when I started investigating all the other lineaments, because there's like a bazillion of them. And of course, every friggin' place on Earth has a lineament going across it. So if you want to learn about the ones in South America, well, then you got to figure out where the one is there, what name do they call it, and then you have to follow it along and see where it goes. Now, I don't know how the neotectonics people are doing it, because I've seen some of their studies where they just call it lineament, or well, not a lineament, but neotectonic line 874 or whatever. They give it a number, and then they follow it the whole way around. So they don't call it the Texas lineament to Sandpoint, Alaska to whatever, like what I'm doing, but it's basically the same thing. And like when I started studying all these things about like what they call suture zones, deep fault, all these different things that all the different people refer to, they're all talking about the same thing. It's just they're using 15 different names to try and describe it from whatever side or angle they're coming from. And that's how it all is. So when I started reading about Walker Lane and the people that are all the experts on Walker Lane, well, the head expert on it is actually at the University of Nevada in Reno. That's where he's based out of. If you actually went and asked him today, he says that Walker Lane actually goes from Haida Gwaii to the Gulf of California. Well, if it's a lineament line, which I think that's what it is, it always has been, it actually goes from North Alaska all the way to South Sandwich Island. And it's all on the same line that all the quakes follow. Like when you get a big one, usually in South America, it goes up that lineament line. But sometimes you get big ones that go down that line too. Like what we had, like with the Alaska ones. So it's all crazy stuff. So you can give all these things different names and then extend them out farther once you see how the quakes are progressing or the volcanoes or whatever. Because you'll find the calderas are all on these same lines. And a lot of the volcanoes are on the same lines too. And if you start studying any of the volcanic lines that are hotspots, well, guess what? They're the same thing. They always go in a line. Northwest to southeast or northeast to southwest. So they're all the same thing. And if you actually get into the study of how they identify all these things now, even an impact crater has a magnetic anomaly at the center of it, just like a caldera does.
If it was solid, if it was ice, it may not.
Well, it doesn't matter because where it hits, like if it made it down where it hit the crust, so it doesn't matter if it's above water or below water, they still can find because there's a whole bunch in the ocean that they haven't even identified yet as impact craters or calderas or super volcanoes or whatever, because they have to get down there and take a core sample of it and figure it out and say, oh, well, look, this is a caldera, this is an impact crater. And then, of course, some you can't see because it's either been subducted or overran or whatever, depending on how long ago all this stuff happened, right? Because all the plates are still moving. So it's crazy stuff, but this is all the things that they're trying to figure out. And when I started looking into the impact craters, it was the same thing. I said, well, look, all the impact craters are landing on these same lineaments that I'm looking up all the other stuff for. So my theory is that these lineaments have always been there, and they're moving everything, and they're also attracting stuff from space because it's all related to how Earth's magnetic field is reacting with all these other things with magnetic fields. To me, that would make sense. And that's why the ancient cities or ruins or whatever you want to call them are all on these lines that all
Mhm.
connect. So if they had to put them there for a specific reason, because why are they all on a line, and they still are, even now, even the ones that are thousands of years old. So that means it hasn't moved that much in that period of time. So if they were accessing, well, my theory is wireless communication and power.
Mhm. Hard,
'Cause
hard to prove
that's
right
what they were
now. We
doing.
need a lot of evidence on that, and I appreciate that idea. I think they understood things way better than we do, and I think over time we've lost quite a bit of understanding of that because our focus is what we can see with our eyes and handle with our hands rather than the other abilities to perceive. And I think that's where you're at. On your screen right now is the Wallapies where I live. If you can see that on your screen there, Canuck and JSL,
Yeah.
you'll see that there are flows of magma at different levels. And the newer would be, I think, would be up at the top, but you see a lot of rock falls at the foot of these mountains. But, plenty of erosion has taken place and multiple lava flows. So just in my little area, again, the Wallapies are behind, and people live up in there, and I live off to the north of this. But this is two pictures put together, by the way, and just the just like what Professor Nick said, these funky looking flows of granite just peel away, and it's far out. But anyway, I just wanted to share that with you. You can continue. I'm sure you can see. Can you see it on your screen?
Yeah, I can see it. Well, they're like pillars,
Yeah.
or
I was
whatever,
looking
like
for a
how
word.
like how the lava solidified or whatever.
Mm-hmm.
Well, we have them here too, but they're just even older.
Yeah.
So
This is just in a little area that I live, and the Wallapies behind are I don't know 9,000 feet high. These things are barely 4. So they're twice as high in the background. But interesting. The Wallapies are an Indian, a natural Native American here, and they're called the people of the pines. That's what Wallapai means. Interesting. Anyway, we're talking about different topographies and the lineaments and how they're created. Home gardens, or Livermore, Fresno, Visalia, all this area can rock and roll. And that earthquake did happen at 1503. But that's not all of them. Definitely not all of them. Today with the USGS, anyway. Looks like Santa Clara had, Simi Valley had a 1.3, a small one. And Coso Range is still banging away. Interesting there. Our whole context, what we're talking about is why does it seem that you can understand quakes along the plate boundary of the San Andreas, but why does it seem to be that there's a line invisible to some, but not invisible to us? Because we know the faults that work through this area, and that's the Texas lineament. And he has them going up to right up here. Here's Kodiak and Port William is there. Sandpoint. I don't think Sandpoint's up that way, is it not?
Yeah, it's down. Yeah, it's down a little bit below Kodiak. Because the owl, if you extend it out, the Olympic wall or liniment, it actually goes more to the eastern side of Kodiak.
Correct. Yeah.
So
Right
it's
up
getting
there.
closer. Yeah, if you go up through there, it's getting closer to Anchorage.
Hmm.
If you keep extending it out.
And there's several volcanoes that are active right up in here in the what is it?
Yeah, you can actually see those seamounts out there actually match the liniment lines if you actually look them up.
Right.
So they talk about a hotspot making those seamounts, but I believe the hotspot and the liniment are all related.
I do too. I think the hotspot is where the spiral magnetic after the core would rise up from the depths of the core and into the surface, creating a vortex of, so to speak, and an upwelling like a bubble would from deep down below rising to the surface. Because it has become lighter, because it created an energy and it changed its composition as it rose from the core. And some people say it's the core breaking down, the iron core breaking down and creating the mercury, creating all these other sub anatomical molecules as it breaks down and it rises to the surface, creating the vortices and of magnetism and drawing all the other like material with it to the surface of the earth. And that's why you get, gold veins, silver veins, and, nickel veins, and all the metals that we use in our everyday life, copper and all the like, even uranium and plutonium and all the other stuff. And then as they come to the surface, they give off other gases, other molecules, and where we get our hydrogen, our helium, and that interacts with what's going on around us magnetically. When the sun hits us, we see mostly a green geomag storm or auroras, but periodically we see blues, reds, greens, yellows. And all of those are different molecular exchanges in our atmosphere at differing levels and at different heats, and just like what comes out of the earth. And I think Canuck, if I'm mistaken, you can correct me. We both think that the sun in our inner core is like the sun, and it has it does what it does. And if you want to elaborate on that, you can.
Well, yeah, it's like a little mini sun because the Earth's core makes a magnetic field, and so there's magnetic fields on the other planets too.
Right.
So my theory is it's the same thing, because now that we're studying the other planets, we're finding the same thing. Like Mars has quakes. All really earthquakes are it moving. So it doesn't matter which planet it's on. If there's solid rock there, it's going to move around. So, and I think it all moves based upon how the cores of each planet are reacting to all the outside magnetic fields that are affecting it. And it's crazy stuff, but that's what they're finding with all this stuff now, because they're finding that tsunamis generate their own magnetic field. So if you could detect when it's doing that, you could be able to figure out when the tsunami was coming way before it got there.
Right.
So there's an example. But now they also say asteroids or space rocks or comets or whatever you want to call them. They're all space rocks, basically.
Right.
they all have their own magnetic field because at some point, wherever they came from or were created in the first place, they were magnetized. This is what all the current
Well,
studies say.
there's a vortice too. It's with spin, like a baseball. It doesn't travel in a straight line. It moves because of the surface of the threads and the spin of the ball. And that's interesting. Hold on a second. Hold on.
But it had okay.
We're at 1 hour, so hold on. I got to put this commercial on. The rabbit hole was created to dive deeper into subjects that needed further examination. Hi, I'm Joe, and my guest and I will take you on a journey of discovery and exploration. We will provide insight and theories regarding the subjects we discuss. Come join us live at joeslicklive.locals.com, or you can join us on Facebook or Twitch or YouTube. Thanks, and look forward to seeing you. And remember, don't get none on you. All right, we're at 1 hour and the other shows will stop. So I'm going to stop this recording and the other one too. It's live, 56 minutes. Ooh, boy. End the stream.